Connecting a 20 amp breaker in the tap panel to supply the camper receptacle and running a grounded neutral wire from this receptacle directly to the grounded terminal of the meter main through existing conduit less than 5 feet connecting all enclosures and not landing it in the tap panel would render the tap illegal. The neutral wire must be landed in the panel that supplies the circuit. In this case, the tap panel is supplying the circuit, so the neutral wire must be landed in that panel. Not landing the neutral wire in the tap panel would violate 408.36b, which requires that the neutral conductor for each circuit be connected to the grounded circuit conductor in the panel board or other distribution equipment that supplies the circuit. Additionally, not landing the neutral wire in the tap panel would create a safety hazard. If the neutral wire were to become disconnected from the meter main, it could energize the metal enclosures of the tap panel and the camper receptacle, which could pose a shock hazard. This explanation delves into the reasons why this wiring configuration is non-compliant and potentially dangerous, referencing the relevant section of the National Electrical Code, or NEC. The scenario involves an existing electrical service with a 200 amp meter main having 200 amp feed-through lugs. The house is fed from two 100 amp 2-pole breakers located in the meter main, which power two separate 100 amp breaker panels in the house. The main lugs in the meter main are tapped following the guidelines of 240.21 to an adjacent 125 amp 6-space main lug panel. This panel has two 2-pole breakers powering two 30 amp air conditioning compressors. The question at hand is whether installing a 20 amp breaker in this tap panel to supply a camper receptacle and running a grounded neutral wire from this receptacle directly to the grounded terminal of the meter main through existing conduit less than 5 feet connecting all enclosures and not landing it in the tap panel would render the tap illegal. The assessment is that it would indeed make the tap illegal. The core issue lies in the proper connection of the neutral conductor. According to the NEC, specifically 408.36b, the neutral conductor for each circuit must be connected to the grounded circuit conductor in the panel board or other distribution equipment that supplies the circuit. In simpler terms, the neutral wire for the camper receptacle must be connected within the tap panel, as that is the panel providing the power to the receptacle. Bypassing the tap panel and running the neutral directly to the meter main violates this requirement. This regulation ensures that the neutral conductor is properly connected to the grounding system within the panel, which is crucial for safety and proper circuit operation. The absence of this connection can lead to several problems. Firstly, it can create a potential difference between the neutral conductor and the grounding system, which can result in unwanted current flow and electromagnetic interference. Secondly, it can compromise the effectiveness of overcurrent protection devices, such as circuit breakers, potentially delaying or preventing them from tripping in the event of a fault. Thirdly, it can create a shock hazard, as the metal enclosures of the tap panel and the camper receptacle could become energized if the neutral wire were to become disconnected from the meter main. The NEC is very specific about these requirements because of the potential for dangerous situations to arise from improper grounding and neutral connections. The code is designed to protect people and property from electrical hazards, and strict adherence to its provisions is essential for ensuring electrical safety. This situation also touches on the definition of a power panel, which is relevant because different rules apply to power panels compared to lighting and appliance panels. The determination that the 125 amp panel meets the definition of a power panel since there is no grounded neutral conductor connected, as per 408.34, is an important consideration in this scenario. However, this classification does not override the requirement for proper neutral connections for individual circuits. Even in a power panel, each circuit must have its neutral conductor properly connected to the grounded circuit conductor within the panel. The installation of the tap itself is also a point of consideration. The tap appears to be code compliant because the ampacity of the number 1 copper tap conductors is less than the combined load and not less than the rating, 125 amps, of the device that they supply. This is in accordance with the requirements of 240.21 bone, which allows for taps under certain conditions. However, even if the tap itself is code compliant, the improper connection of the neutral conductor for the camper receptacle would still render the overall installation non-compliant. The code provides specific rules for tapping conductors to ensure that the tap conductors are properly sized and protected. The tap conductors must be protected from overcurrent by an overcurrent protection device that is sized to protect the conductors. The tap conductors must also be installed in a manner that protects them from physical damage. The tap conductors must be terminated in a code-compliant manner. In summary, the correct way to wire the camper receptacle in this scenario is to install a 20-amp breaker in the tap panel and run both the hot and neutral conductors from the breaker to the receptacle. The neutral conductor must be connected to the neutral terminal block within the tap panel, which is connected to the grounded circuit conductor. This ensures that the neutral conductor is properly grounded and that the circuit operates safely and in accordance with the NEC. Ignoring this requirement and running the neutral directly to the meter main would create a code violation and a potential safety hazard. It's important to remember that electrical work should always be performed by qualified individuals who are familiar with the NEC and local electrical codes. This helps to ensure that the work is done safely and correctly, minimizing the risk of electrical hazards. Furthermore, regular inspections of electrical systems are crucial for identifying and correcting any potential problems before they can lead to accidents or equipment damage. These inspections should be performed by qualified electrical inspectors who can identify code violations and other safety concerns. In addition to the specific issue of the camper receptacle wiring, it's also important to consider the overall capacity of the electrical service. The existing service has a 200-amp meter main, which may or may not be sufficient to handle the additional load of the camper receptacle and any other appliances or equipment that may be used in the camper. It's important to perform a load calculation to determine whether the existing service is adequate. If the load calculation indicates that the service is overloaded, it may be necessary to upgrade the service to a larger size. Upgrading the service can be a significant expense, but it's important to do so to ensure that the electrical system can safely handle the load. It is important to verify that the existing wiring and equipment are in good condition. Over time, wiring can become damaged or deteriorated, which can create a safety hazard. It's important to inspect the wiring for any signs of damage, such as cracks, breaks, or corrosion. If any damage is found, the wiring should be replaced. Equipment, such as circuit breakers and receptacles, can also wear out over time. It's important to test the equipment to ensure that it is functioning properly. If any equipment is found to be defective, it should be replaced. Grounding is the intentional connection of a circuit conductor to the earth. Grounding is used to protect people and equipment from electrical shock. There are two types of grounding: system grounding and equipment grounding. System grounding is the grounding of the neutral conductor of an electrical system. Equipment grounding is the grounding of the non-current carrying metal parts of electrical equipment. The purpose of system grounding is to provide a low impedance path for fault current to flow back to the source. This will cause the overcurrent protection device to trip and to energize the circuit. The purpose of equipment grounding is to provide a low impedance path for fault current to flow back to the source. This will prevent the metal parts of electrical equipment from becoming energized, which could cause an electrical shock. Grounding is an essential part of electrical safety. It is important to ensure that all electrical systems are properly grounded. Bonding is the intentional connection of metal parts to form an electrically conductive path. Bonding is used to ensure that all metal parts are at the same electrical potential. This will prevent electrical shock. Bonding is required for all metal parts that are likely to become energized. This includes metal water pipes, metal gas pipes, metal conduit, and metal enclosures. Bonding is an essential part of electrical safety. It is important to ensure that all metal parts are properly bonded. Overcurrent protection is the protection of electrical circuits from excessive current. Overcurrent can be caused by a short circuit, an overload, or a ground fault. Overcurrent protection devices such as circuit breakers and fuses are designed to trip and de-energize the circuit when the current exceeds a certain level. Overcurrent protection is an essential part of electrical safety. It is important to ensure that all electrical circuits are properly protected from overcurrent. Arc fault circuit interrupters, or size, are devices that are designed to protect against arc faults. Arc faults are a type of electrical fault that can cause fires. Size are required in many areas of the home, such as bedrooms and living rooms. Size are an important part of electrical safety. It is important to ensure that all electrical circuits are protected by size where required. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect against ground faults. Ground faults occur when current flows through an unintended path to ground. GFCIs are required in many areas of the home, such as bathrooms, kitchens, and outdoor areas. GFCIs are an important part of electrical safety. It is important to ensure that all electrical circuits are protected by GFCIs where required. Surge protection is the protection of electrical equipment from voltage surges. Voltage surges can be caused by lightning, power outages, or other events. Surge protection devices are designed to divert the surge current away from the electrical equipment. Surge protection is an important part of electrical safety. It is important to ensure that all electrical equipment is protected by surge protection devices. Electrical safety is an important topic that everyone should be aware of. By following the safety tips in this guide, you can help to protect yourself and your family from electrical hazards. Here are some additional tips for electrical safety. Never work on electrical equipment unless you are qualified to do so. Always turn off the power before working on electrical equipment. Use caution when working near water. Never overload electrical circuits. Inspect electrical cords and equipment regularly for damage. Replace any damaged electrical cords or equipment immediately. Install smoke detectors and carbon monoxide detectors in your home. Test your smoke detectors and carbon monoxide detectors regularly. Have your electrical system inspected by a qualified electrician every few years. Follow all electrical codes and regulations. Be aware of the electrical hazards in your home and take steps to prevent them. By following these safety tips, you can help to protect yourself and your family from electrical hazards. The National Electrical Code, or NEC, is a set of standards for the safe installation of electrical wiring and equipment in the United States. The NEC is updated every 3 years by the National Fire Protection Association, or NFPA. The NEC is not a law, but it is widely adopted by state and local governments. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and bonding. The NEC is an essential resource for electricians, contractors, and other professionals who work with electricity. The NEC is available for purchase from the NFPA website. The NEC is also available for free online from various sources. However, it is important to ensure that you are using the latest version of the NEC. The NEC is constantly being updated to reflect new technologies and safety concerns. Using an outdated version of the NEC could result in unsafe electrical installations. The NEC is a complex document, and it is important to have a thorough understanding of its provisions before attempting to install electrical wiring or equipment. If you are not familiar with the NEC, you should consult with a qualified electrician. The NEC is an essential tool for ensuring electrical safety. By following the provisions of the NEC, you can help to protect yourself and others from electrical hazards. In addition to the NEC, there are also many other resources available to help you learn about electrical safety. The Electrical Safety Foundation International, or ESFI, is a non-profit organization that is dedicated to promoting electrical safety. ESFI offers a variety of resources, including educational materials, training programs, and public service announcements. ESFI also publishes a variety of articles and reports on electrical safety topics. The Occupational Safety and Health Administration, or OSHA, is a federal agency that is responsible for ensuring worker safety. OSHA has a number of regulations that cover electrical safety. OSHA also offers a variety of training programs on electrical safety topics. The National Institute for Occupational Safety and Health, or NIOSH, is a federal agency that conducts research on worker safety and health. NIOSH has published a number of reports on electrical safety topics. There are also many other organizations that offer resources on electrical safety. These organizations include trade associations, labor unions, and consumer groups. By taking advantage of these resources, you can learn more about electrical safety and help to protect yourself and others from electrical hazards. Electrical safety is everyone's responsibility. By being aware of the electrical hazards in your home and workplace, and by taking steps to prevent them, you can help to create a safer environment for yourself and others. When dealing with electrical installations, especially when tapping into existing panels, always consult with a licensed electrician. They can assess the existing system, perform necessary load calculations, and ensure that all work is performed in accordance with the NEC and local electrical codes. Remember that electrical work can be dangerous, and it's always best to leave it to the professionals. The information provided here is for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Improper electrical work can lead to serious injury or even death. Be safe and take the necessary precautions. Firstly, always disconnect power before working on electrical circuits. Secondly, use insulated tools designed for electrical work. Thirdly, wear appropriate personal protective equipment, including safety glasses and gloves. Fourthly, never work alone. Fifthly, double-check all connections before energizing the circuit. Sixthly, if you are unsure about anything, consult with a qualified electrician. Seventhly, respect the power of electricity and always take safety precautions. Eighthly, follow all applicable electrical codes and regulations. Ninthly, keep your work area clean and organized. 10thly, be aware of your surroundings and potential hazards. When it comes to electrical installations, safety should always be the top priority.